Hello, my name is Giovanni Hernandez and I want to teach you guys about factoring. So let's dive into what factoring is first. So what is factoring? So factoring is basically a process to break up a polynomial into a product of terms. So that can be either breaking up a polynomial, which is an expression made up of multiple terms, such as like 2x squared plus x, and we want to break up this polynomial into a way where we can have multiple terms that are multiplied by each other, which is showing you that a product of terms is what we're trying to accomplish. So let's say we take out the x out of these two terms, and we have x times 2x plus 1. Right here we can see we have a binomial and a term that is being multiplied to the binomial. Therefore we have two terms, this term, the binomial, and this term, the x, which is going to be a product, and that's going to be a factor. So these two are going to be factors that multiply together to get the polynomial above. So there's two methods we want to focus on, the GCF method and the x/the box method. So what is the GCF method, and when should we use this method? Well, when a common factor is found in all terms of a polynomial, you should always use this method first. So let's say we have like a big polynomial like 100x squared plus 50x plus 2. Although this is something that we typically wouldn't solve ourselves, we can identify that there's a common factor in all these terms, and that is 2, because 50 times 2 gives you 100, 25 times 2 gives you 50, and 2 times 1 gives you 2. So that's how we know we can find the GCF method, and that can be simplified to 50x squared plus 25x plus 1. So the GCF method is going to be typically used to just make sure we have an easier time in navigating these problems and just sort of get a simpler term. So you should always use the GCF method to begin with. So how about the x/the box method? Well, we should use this method when typically a polynomial has at least 3 terms. Sometimes you can use it with 2 terms with a binomial, but typically with trinomials and those. You want to make sure you simplify with the GCF method if possible. So you typically really want to focus on this GCF method, as it is like the bread and butter of just making your life easier for all factoring needs in math. And I personally feel like we should always just start off and see if we can factor any of the factors or any of the terms using the GCF method to get our factors. So let's look at the first problem. Let's look at 5x squared plus 10x. So let's highlight our terms to begin with. Let's see, we have 5, we have an x squared, we have a 10, and we have another x. So important to note, we're looking at the coefficients of 10 and 5. They're coefficients because they're in front of the variables. And we're going to also look at the variables found in this problem, which is x and x squared. So let's see. Let's start off by seeing if we can break down any of these polynomials, or any of these terms down, using the GCF method. And how I like to do this is by creating a tree. So let's do 5 right here, and we'll do 2 branches, stemming down. So what 2 terms come up to make this factor? Let's see. We can multiply 5 times 1 and we get 5. And I don't really think there's any other terms that you can multiply by 5 or by 1 to get 5. So let's try 10. If we get 10 and create 2 branches down to the side, what 2 terms can be multiplied to get 10? And typically you can do 5 times 2, because there's nothing else that you can multiply times any other number to get 10. Well, any whole number at least. So we know by looking at these 2 branches, these 2 tree branches, that we can see there's a common factor. And the greatest common factor is 5 in both of them. As we can see, 5 times 1 and 5 times 2. So that means we can take out the 5. So then we can take out 5 and multiply that by 1x squared plus 2x, because that's what the other term is left for both trees. And then you can decide whether you want to write 1x squared or just erase it and be left with x squared. Either way works, whatever makes you more comfortable. But then we're not done yet. I still feel like there's something there. And as we can see, we can do x squared to the side and we can do x to the side. So if we create two more branches down here, we can see what terms we can multiply to get those products. So if we write down x times x, we'll get x squared. And if we do x times 1, we'll get x. So then we can also identify that x is the greatest common factor in both of them. Let me use a different color. X is the greatest common factor in both these equations. So we can take that out, put it outside of the parentheses, and we can do 5 times x plus 2, because x is going to be left from this one times 1. That's going to leave you with x, and then you're going to be left with 2 times 1, which is going to leave you with 2. So then, to finalize the GCF method, you can just multiply these two terms on the outside that are taken out. So you're left with 5x times x plus 2. It's important not to forget that the 5x is being multiplied into both terms. And that's how we get a factor, because the 5x was taken out of both terms. And that is the GCF method. So then let's take a look at problem number 2, using the x/the-box method. And to begin with, like I told you when we looked at the x/the-box method slide, always want to take a look using the GCF method. So let's look at 2 and see if we can branch that out, and we get 2 times 1. We do 8, branch it out, we get 4 times 2. And we do 5, I accidentally made a little mistake right there. My apologies. And we do negative 10. And we can do, well, we don't really have to include the negative. We can just delete the 10. So we can do 5 times 2. And the common factor in all those terms is 2, as you can see. 2 is found in each of those. So we're going to take out 2 out of all these terms, and we're going to be left with 2 times x squared plus 4x minus 5. And although we could see if we can take out an x out of all these terms, you can see that 5 does not have an x, or have a variable that we can exclude from all the terms. So we're just going to leave this equation. We're going to try and use the x/the-box method on the x squared plus 4x minus 5. So let's look at the x squared plus 4x minus 5. So the x method includes creating a little x to the side. So let's just create an x where the top is going to be a times c, and the a times the c is gathered from your basic formula for a polynomial or a trinomial, which is ax squared plus bx plus c. So then we're also going to be looking at the coefficients of the numbers, or in the constant at the end. So we do 1, which is in front of 5, which is front of x squared, and 5, or negative 5. Really make sure you take into account the negative 5. So then the top number is going to be negative 5, and then in the bottom space we're going to be looking at b. So what's our b term? Our b is the coefficient of x, or our second term, which is going to be 4. So then the x method uses this as a way of saying what two terms can we multiply to get negative 5, but then they both add up to give you positive 4. So let's do negative 5 and 1. So if we do negative 5 times 1, we know that negative 5 times 1 is going to give you negative 5. And then negative 5 plus 4 is going to give you negative 4. So then, knowing that, we may as well just switch our negative to the other side. And there's no problem in guessing and trying. So then we do 5 times negative 1, and that's still going to give you negative 5. And then 5 plus negative 1 is going to give you positive 4. So there we go. We have our two terms. So we can separate this out to x squared plus 5x minus x minus 5, and then we group them up, so we get x squared minus x, little mistake, minus x, and then plus 5x minus 5, and we're going to take the GCF of both sides, so we're going to do x times x minus 1 plus 5 times x minus 1, and then we're left with our final equation of x minus 1 multiplying to both the terms of x plus 5, and then bam, we have factored this entire equation using the x/the-box method. To review, make sure you use the assessment paper given to you at the end and just try out all the problems given, and good luck!